have no idea what an embedded system is.
I don't know. I don't know. Embedded system.
An embedded system?
Embedded?
Yeah.
No. What is it?
I have no idea.
Isn't an embedded system?
Offhand, only because how it sounds.
I have no idea.
No idea.
Really no idea. Never heard of it.
Something that is,
Debbie?
It's a software system that is encrypted, right? It's encrypted, right?
that has either...
Pretty ignorant about it, but...
I don't know what an embedded system is.
is attached to or is...
Wouldn't know.
Haven't a clue.
is within it a... see, I don't know. I'm just going, you know, I don't know.
"6,000 years from the invention of the written word to the first electronic devices. Then 40 years to the first transistor. And then just 11 years to the first integrated circuit.
Guidance is internal. 12, 11, ignition sequence start. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff.
We've gone to the moon and back, are exploring our solar system and beyond.
It's one small step for man, one giant leap for mankind.
Using the same brain our ancestors used at least 30,000 years ago. How did we do it? Thanks to our accumulated knowledge. And in recent years, thanks to the embedded system. As embedded systems become more complicated, embedded systems engineers are debating just what an embedded system is. ENIAC was originally meant for the single function of computing trajectories. Was that an embedded system? Surely an instrument that reports via a web interface is embedded. But is a blade server that only serves web pages an embedded system? A PDA? Perhaps only embedded systems engineers care what is or isn't an embedded system. Although today's end user often doesn't know an embedded system from an embedded reporter.
You know, quality journalism wins out.
They are ahead of us in their acceptance and demand for multifunction single devices. Our concept of embedded systems was born when the integrated circuit came into being in the late 1950s. The first modern embedded systems literally went out of this world. The Minuteman I guidance computer was built from transistor logic and had a hard disk for main memory, comprising 2,500 words distributed over 21 tracks. It sported a 24-bit word and a 30-millisecond cycle time. It weighed in at 70 pounds, occupied 1.5 cubic feet, and consumed 250 watts, about the same as a PC today. Price each, about $1.8 million. Minuteman II was the first system with a large amount of integrated circuits, 2,000, some analog, some digital, and weighed half as much as its predecessor. Still used today, Minuteman III guidance computer was just upgraded in March 2008 to replace the 1970s vintage electronics. In 1961, work on Apollo guidance computer began, and NASA installed the first version in a spacecraft in 1965. The version that went to the moon occupied half a cubic foot, weighed 70 pounds, and required 70 watts at 28 volts DC. The 16-bit machine used 4,000 integrated circuits. Memory consisted of 2,000 words of traditional core for RAM and an unusual 36,000 words of read-only core rope in which the program was stored. To change the program, the computer had to go back to the factory. Automatic updates didn't mysteriously land on their computer in the middle of the night. The code was written both in assembly and in a custom-interpreted language. A simple non-preemptive cooperative RTOS could manage up to 8 tasks. On Earth, the next generation of embedded systems appeared in industrial control, aeronautics, and consumer products. The first electronic handheld calculator, invented at TI in 1967, was the first mini calculator to have the high degree of computational power found only in considerably larger machines. Containing 4 integrated circuits, the calculator was created using this lab test bench, obviously prior to computer-aided design software. But these were purpose-built CPUs. For a few years in the 1970s, a variety of mini-computers from many companies found niches in embedded-like apps. DEC's PDP-8, at $120,000 in today's money, was probably the first machine cheap enough to be embedded into purpose-built equipment, like lab instruments controlling experiments and industrial controls. Some machines were specifically designed for time-sharing and for business applications. As the PDP-8 became smaller, cheaper, and available as chipsets, OEMs used them to create embedded systems sold under other names. Described as the Model T of the computer industry, the PDP-8 is historically important for advances in technology, I/O, software development, and operating system design. Many of our modern architectural features trace from the PDP-8. Then, in 1971, a struggling small semiconductor company invented the first commercial microprocessor, the 4004. That small company? Intel. With the 4004, embedded systems truly began. Built by Intel for the BusyCom calculator, the 4004 was a 4-bit CPU measuring 1/8 by 1/6 of an inch and delivering about the same computing power as the ENIAC, which filled an entire room and used 18,000 vacuum tubes. With 2,300 transistors, the 4004 had an initial clock speed of 108 kHz, could execute 92,000 instructions per second, and used 10-micron silicon gate enhancement mode PMOS technology. The 4004 changed both the hardware and software worlds. Most systems were easily reprogrammable. With the 4004 came the idea of creating software buried in a difficult-to-change medium, like ROMs or EPROMs. Since firmware was so difficult to change, and most embedded systems had no programmer's console or interface, the edit, compile, test cycle was impossibly painful. Intel ultimately came up with the Intellect 4, the predecessor of the in-circuit emulator. The 4004 became the first commercially available microprocessor. It and chips that quickly followed replaced all mini-computers in the embedded space and spawned entirely new products that could only exist due to truly inexpensive computers. Processors soon found their way into traffic signal controllers, telecom network components, ICBMs, and eventually, virtually every electronic device. From such early beginnings, the number of processors has literally exploded. Now, embedded systems are everywhere. If embedded systems are everywhere, we should know what they are, right? Clearly, this is a stealth industry, even though we produce billions of embedded systems every year. We can only guess at what the future will bring. The future is endless. Go forth and be creative.
Happy birthday, Embedded System Conference. I'm glad you made it this far. Good work. I think there's going to be something like those magazines, whether it be purely electronic, whatever, for years to come, because the world needs them. And there's going to be something like this conference for years to come. You know, I wish you Godspeed, and I hope you're around in another 20 years.
Best of luck, and I hope in the future we will have even more reliable hardware and even better programming techniques so that the software can be good and solid, because we will really need it. Our lives depend on it.
Happy 20th birthday. Just think, in 12 months you'll finally be old enough to drink, and then I really won't trust you with my car at all.